You'll be insulted by what I'm about to say.
It is so specific that it's actually named after the company.
A toilet doesn't sound very technological. And ceramics and materials used to make the toilet is quite special.
Welcome to Supply Chain. I'm Tim Culpin of Culpium.
And I'm John from Asianometry.
John, there is so many fascinating Japanese companies in all arenas.
And it's more than just Nintendo.
Or Sony, yes. Today, I want to talk about Toto, not the little dog in The Wizard of Oz, but the toilet maker who does a lot more than toilet. People love their Toto washlet. But I know you've been doing some research into Toto and weirdly their role in the semiconductor industry. So how the heck Toto, the toilet maker, became a major player in the chip industry?
It is kind of weird, isn't it? Like Toto, something you see in a bathroom suddenly is like a dominant supplier in the semiconductor industry.
It's fabulous.
You wouldn't really expect it, but
I
so
love
it goes.
I love it.
Like Toto started out in sanitary ceramics. They like to call it that, sanitary ceramics. They were founded in 1917 as Toyo Toki. The company's early specialty. I mean, they've always considered themselves special in terms they're a tech company in a sense, where their know-how is ceramics, casting ceramics, and firing ceramics. And that's been they have papers published about how they manipulate clay to do a ceramic, advanced ceramics.
So the technology is in the process, even though the final product is not considered technological.
Yeah, it's an interesting thing where a toilet doesn't sound very technological, and it kind of isn't. But the ceramics and materials used to make the toilet is quite special.
Right.
And that's been kind of Toto's thing, where they mastered the ceramic to make it. So they've made toilets for, I would say, 60 years. But then after the first oil crisis, right? And
that's the 1970s.
Yeah, mid-1970s. 73 was the first one. It wasn't a big one, but 76 or 78 was a bigger one. And then also as Japan's housing market got a bit stagnant in the 70s, Toto was like, look, we can't just rely on providing housing equipment, or faucets, toilets, all that, sinks to companies. We can do more. So they, it's actually a very common process for these Japanese companies, but they started branching out and researching new end user applications for their core know-how, which they consider to be structural precision ceramics.
So the idea is we've got this ceramics, which we put into sinks and toilets and basins, which essentially is driven by the housing market. More houses and apartments get built, we sell more of this. The housing market starts to slow down. Hey, we've got this great know-how and technology. How else can we use this?
Right. And they were they didn't see themselves as this is a sink company trying to do other things. They saw themselves as a ceramic company finding new applications for ceramic. And so what happened then was that they went into various technologies, but one of the things that kind of really jumped out at them was semiconductors. So they first started out jumping into packaging. So that's kind of like semiconductor packaging. So if you don't know, chips need to be protected. You don't just take a silicon die and just throw that into your pocket, right?
So when people actually see a chip, they don't actually see the chip. They see the ceramic coating on the outside.
Right. And they kind of went in there for a little bit, but that didn't necessarily do well because that market is already really competitive. The money isn't quite there, and there were already very big competitors that kind of had escape velocity in that industry. They couldn't really do that. So they withdrew from that market, and then they started doing other stuff, and they came up with one product called the electrostatic chuck.
Chuck. Tell me about a chuck.
A chuck is basically a slab of ceramic that's charged, and what it will do is that you take your wafer, your silicon wafer, and you put it on the chuck, and you electrify. I'm pretty sure there's someone in the chuck industry who's going to be really mad that I'm like describing it in this way.
We look forward to emails from chuck experts.
If you are the chuck expert, and I actually know a few, you will actually you'll be insulted by what I'm about to say. But
supplychainpod@gmail.com. Tell us.
The chuck holds the wafer down. Basically, no vacuum, just statics. It's a ceramic component, but it holds the wafer. And so they had this really cool chuck, electrostatic chuck, and they're like, well, what can we use it for? What can this hold thing? They first went into semiconductor lithography.
Right.
Like lithography, that's the top.
It's the cool stuff.
The core stuff that makes the most money. Chuck makers, you had big lithography companies in Japan at that time, Nikon, Canon, they were really big. They could buy this chuck thing and integrate it into their tool.
Makes sense.
But the Canon and the litho guys were like, look, we don't need this chuck. We have vacuums. We have vacuum things. It'll just suck on. It'll just use the vacuum to hold the wafer solid. We don't need to change that. Get out of here. So Toto was like, oh, well, we're going to flush that one down the drain. And then, but then they pivoted and they went into the thing that goes after litho, which is etch.
Ah, yes.
And the thing about etch, unlike litho at that time, etch was done in a vacuum. You had to do it in a very demanding environment where the chuck cannot be holding the wafer by vacuum. And so, because it's in a vacuum, and you can't use a vacuum to hold on a vacuum.
Right.
So, they started doing this for, I would say, a couple years.
So the electrostatic property of the ceramic that Toto had developed could be used to hold the wafer in the place of vacuum, because a vacuum was not a viable option. So they could use the electrostatic plate of the ceramic chuck.
Correct.
Cool.
Right. And so in 1988, they started getting into the etch industry, electrostatic etch industry. And that was kind of like one of those things where, it's not just making a ceramic disc, right? You have to create this really high precision ceramic plate, which has very controlled electrical properties, has to handle incredibly challenging environments, which is you might have acids floating around, you might have various electric, static and plasma, a lot of very bad things. So Toto built a product that was very durable and also one other thing, the wafer cannot be contaminated.
Ah, of course. It's got to be perfectly clean.
Right. The chuck cannot actually shed
or deteriorate, right?
Or help break or contaminate the wafer. So that was a big thing that Toto worked on. So anyways, they went into this industry for 1988, and they kind of dilly-dally through it in the 1990s and the 2000s and the 2010s. And now suddenly, it's like suddenly a really big thing. You know why?
Tell me.
3D NAND.
3D NAND.
Yeah, 3D NAND.
So that is basically skyscrapers of silicon.
Right. 3D NAND is the most scalable semiconductor in the industry today.
Why is that?
Because the way to make 3D NAND is that you stack layers like what's that cake that's like really delicious?
Milfie.
Like a milfie. Milfie?
Milfie.
Milfie.
Yes.
Milfie. So you're going to
1,000-layer cake.
1,000-layer cake. And then at the end of it, you punch a hole through this 1,000-layer cake and you fill it with crap. Not literal crap, but crap.
I mean, we're talking Toto here, so.
And then you give it powers and it suddenly stores your data of your cats. So that's NAND, 3D NAND in a nutshell. It's a revolution in the flash memory industry. And right now you're getting all these competition between companies putting together huge stacks of NAND.
How high is it now these days? 3D NAND.
I think what they're shipping is something like 300 or something. It's like really weird numbers, like 321. of something like that.
They're very weird denominations, aren't they?
Right. And that's partially because the maximum, for reasons I have not sufficiently researched so far, is there's a constraint where you can only do 143 layers max per like milfy cake, right?
That is such a random number.
I do not know why it's that number.
And so you could do 143, 286, and so forth.
Yeah. And then they might do, so like there you have a 430, which is 3 tiers of 143. I don't think they'll do the full 143 for that one. And then 570 and so on. So basically that's been
Koto's thing.
Yeah. Total thing.
But they're not the only ones, the only Japanese company that's gone from some totally unrelated industry to this one. There is, I know, something that's very hot right now, ABF, Ajinomoto build-up film. It is so specific that it's actually named after the company. But Ajinomoto is not a semiconductor supplier at all, or a semiconductor chemical company traditionally. Who is Ajinomoto?
Ajinomoto Group started off for food products. They did umami seasonings.
Wow.
MSG. They are the dominant supplier of MSG in the world.
Wow. Monosodium glutamate then is a key ingredient for semiconductor making.
And delicious Chinese food.
Different type of chips, remember, people.
So the story of Ajinomoto build-up film, it's actually quite hard to find, even though they've kind of publicized it, but they put it in a lot of weird Japanese stuff. It started, ABF began as a desire by corporate to find uses for byproducts in production of MSG. So what they would do is, so they brought in a guy named Koji Takeuchi, and his job was to just find these uses for these random byproducts that would otherwise be thrown away. And after struggling for a while, one of their kind of colleagues suggests you should look at the computer industry, right? And the computer industry, so he goes to the computer industry, which was rapidly growing in Japan at that time. And I think this is the 80s or so. And they one of the manufacturers requests that you could do this, ask basically, can you make a substrate? You had these computer circuit boards, right? And they have substrates on them. And what he needed was a special, they were using this liquid ink. Mm-hmm. And when you put down this liquid ink, and you had to wait for it to dry. Mm. So they were basically asking, can you have a solid version of this ink to put onto the substrates for these circuit boards? Huh. And so Ajinomoto was like, okay, this is weird. And so they basically, it's like an insulating kind of liquid, a solid. Mm. And they put together a team, and I think through a span of maybe 4 to 6 months, they had no idea if they could do this. And through pure trial and error, they managed to put together this film, basically, this solid film. And so they were so they said, oh, we have this film, right? He goes in and they try to sell it, but then no one buys it because no one wants to buy from a food products maker in Japan. There's
no legit track history of this company supplying premium, high-precision chemicals to the semiconductor industry.
Computer industry,
You just make food additives, dude. We're not buying your stuff.
Right. So it was like no one was going to buy this. And then, so Ajinomoto was, the company, the corporate was like, okay, this is not going to work. Let's just put this, let's throw it, let's move on. But the team members actually, the team leader, Takeuchi, was basically like, I still believe in this product. I still believe there's a possibility. So instead of disassembling his team, he basically arranges strategic transfers, putting them in different parts of the team, and he would move into different parts of the company and he would tell all of them, I will someday bring you back. Don't worry. I will find a use for this. I will sell this.
Like a Horcrux in Harry Potter.
Right.
Distributed throughout the empire.
Right.
To be put back together.
Right. And so in 1998, a supplier for a big semiconductor company, I don't know which, but you might be able to guess, shows interest in using ABF for high performance computing. And basically, they didn't care whether or not that Ajinomoto was a food company or whatever. They just said, can your product actually do what it's supposed to do? And yeah, it could.
And he put the band back together.
He brought the guys back together. And then after many years, Ajinomoto build-up film is now like it's a monopoly in this field. It makes hundreds of millions of dollars a year. It's one of those crazy Japanese stories, which has something I've seen frequently where you have this one guy, this team member, who somehow persists even though everyone else is telling him.
The mad scientist who won't give up.
Right. I mean, I've seen this with notebooks as well. But it's just they persist with the product for years. It's a very interesting sort of story.
I love that story. The other one is a company that has, to me, some similarities to Nokia. Because Nokia was in rain boots and stuff like that, like a century or more ago, industrial products. Mm-hmm. And then famously became a cell phone maker for a couple of decades. Mm-hmm. And so the next company I want to talk about is JSR, which also started off in rubber products, right? Mm-hmm. How did they then become a key supplier to the semiconductor industry?
This one, JSR, is kind of like an interesting company because they didn't necessarily get into the rubber stuff until, it actually comes in the same line as after the energy crises of the 70s, when suddenly making synthetic rubber actually for them at that time required a good amount of petroleum and energy, heavy industry. And I think they recognized, or maybe they were told by the government, that they could no longer rely on cheap energy and cheap oil to kind of build their product. So they just started started trying everything. And I think one of the lucky things for them is that they knew how to make this photoresist that wasn't the leading in the market, but it was new.
And it was good enough.
It was fairly good enough, yeah.
So just quickly, what is a photoresist? Just give me the rundown quickly on that.
Photoresist is kind of the chemical. It is a chemical that you apply onto a wafer. And when you flash the chip design in the lithography exposure tool, the photoresist is supposed to hold on to the design. And then you wash off the non-exposed, or if you have a different type of photoresist, you wash off the unexposed. And then it would serve as a kind of a hardening to during the etch step, which we talked about earlier, the etch. And they call it resist because it resists the etch. It comes from photography from 100 years ago. So JSR basically got into this, and it worked for them because they made synthetic rubber, right? They made synthetic rubber for tires. Their first photoresist product was made from a material derived from synthetic rubber.
Interesting. Brings me to my next company that I want to briefly mention. Kodak was famous in the photo industry. They kind of pioneered modern photography, well, pre-modern photography before digital. But another company that also then came along was Fuji, or Fujifilm. Now, Kodak has basically disappeared, but Fujifilm is still alive. And talk to me quickly about why that's the case. They're still surviving and doing quite well, whereas Kodak has essentially disappeared.
It's kind of interesting because it kind of goes back to what I mentioned earlier, where Kodak kind of thought themselves as the company that controlled the concept of photography, right? They controlled the idea of imagery and camera. They made a lot of money from selling film, cameras, and all that. But they thought of themselves as like, we are the memories, like we kind of help preserve people's memories or something. They're really something lofty. I think Fujifilm always saw themselves, on the other hand, as a technology company that happened to make film and cameras at that time. So when you started to have digital come in, and digital kind of turned Kodak's market. Kodak's traditional profit generator was the film, right?
Yeah.
And so when you have digital basically destroys all of that, right? And CMOS imagery or CCD and all that got cheaper and cheaper. And Kodak went into digital cameras because they thought to themselves as something as like,
This is our thing.
This is our thing. We're a photography company, right? I think Fujifilm sort of recognized, I mean, they made some of that stuff too, but I think that a digital camera as a product is a pretty terrible product margins-wise because it's a bunch, the value is in that CMOS chip.
And there's not a lot of ongoing revenue.
Yeah, you don't
There's
have
a lot of disposable.
You don't sell film.
Yeah.
You don't sell film for digital cameras. So I thought so the Fujifilm basically thought themselves, they went back to the kind of the drawing board as they recognized this photography business wasn't going to send them to the future. And so they started basically pulling everything out of what they knew about making film to make new types of applications and technology. So exactly what I talked to you about with Toto, right? When Toto, they didn't see themselves as a toilet company. They saw themselves as a technology company of ceramics that sold in the form of toilets. Fujifilm saw themselves as kind of like a photography film type technology company that happened to do cameras for some time and film for some time, but now they're going to do something else.
So that allowed them to pivot much more easily because of the way they viewed the product that they made.
It's like sort of like an insane sort of like, they were like, look, we need to, it was a mindset change, right? So they made healthcare imaging. They turned their film expertise into kind of a protective LCD film that you put on top of LCD screens. That makes good money for them. They got into office equipment through Xerox. But I think it's like that's one of the things that this sort of diversification basically through the 2000s was like a rush, but they managed to build out and expand their business without and not let that photography destroy it. I would always argue that Kodak allowed photography it allowed itself to be taken down by this obsession with photography. They had a chemicals company and they kind of sold it or spun it off as it's still around. It's the Eastman Chemicals Company.
Right.
So I think they really kind of put themselves in the hole on their own.
But Fuji didn't. So it's interesting. We've got Toto, Ajinomoto, JSR, and Fuji, 4 Japanese companies that really saw the changing macro environment around them and adapted. Very Darwinistic. They realized that their existing cash cow businesses were not going to be viable forever and had to find ways to adapt and found the base of their company, the base product of their company was the foundation which they could move into a new market, which I think is fascinating.
It tells you where they think their expertise is.
Yes.
It's not the product. It's the technology behind it.
Agree.
It's a very Japan thing.
It is a very Japan thing. Well, this has been another episode of Supply Chain. I'm Tim Culpin of Culpium.
And I'm John from Asianometry.
Thanks for listening.